Now, let's reduce the fourth power to the first power. So the question says that we have to reduce sine theta to the power 4 to an expression involving only a function of a multiple of theta raised to the first power. So what this means is that basically you need to convert this sine theta to the power 4 into a constant being multiplied with a function of theta. But the condition on this is that it must be a linear expression of theta. Okay, so there must not be any square terms after the constant, not a single one, not even the bracket. That must not be a square term either. Okay, so how do you do that? Well, obviously we'll need to use identities, and we only know how to use identities on squares of trigonometric functions. So the first thing logically would be to convert this sine theta to the power 4 into sine square theta whole to the power 2. Okay, so now we have to deal with just this sine square theta inside this bracket. So the first thing you'll do is you'll have to apply the half angle identity on it. So so that this square term inside can be eliminated. So once you apply the half angle identity on sine square theta, you get 1 minus cos 2 theta over 2. And I've told you how to do these half angle identities before, but again let me just show you a simple way of how we got here. It's because sine theta by 2 is equal to under root of 1 minus cos theta over 2. And so now instead of this theta by 2 you have theta, so obviously instead of this theta you'll have 2 theta. Okay, and obviously since it's sine square theta, that means this entire term must be square, and this one as well, this will be square as well, so you can cancel out the square term. And so that's why you have 1 minus cos 2 theta over 2 instead of under root 1 minus cos 2 theta over 2. Okay, so this is a smaller explanation, but now we need to eliminate this square as well, the square that is applied on the bracket. So the first thing you'll have to do is take this divided by 2, which means basically being multiplied with 1 by 2 outside of this bracket. So you'll take, so this is not 1 by 2, it will be 1 by 4 outside of the bracket because of this square. So it will become 1 by 2 square outside, so 1 by 4, and then you'll take the square of the numerator, which is 1 minus cos 2 theta. So once you expand 1 minus cos 2 theta whole square, once you expand that, you get this 1 minus 2 cos 2 theta plus cos square 2 theta. Okay, fairly simple so far, but now we have another square term over here and we need to eliminate that. So again you'll apply the half angle identity on it, and so you'll get this 1 plus cos 4 theta over 2. And what you'll do now is you'll take the LCM over here, so you can take this, so eventually you can take this term outside with this 1 by 4. So once you take the LCM, you basically get this entire term divided by 2, and obviously once you take that 2 outside and multiply that 1 by 2 out, when you take this 1 by 2 outside and multiply it with 1 by 4, you get 1 by 8. Okay, which is why you have this 1 by 8 over here. And now you have a constant 1 by 8 multiplied with a linear function of theta, because there is no square term at all anywhere. And so you can just again add this 1 to this 2 and you get this. So yeah, that's how you do the question.